This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 3, Fan Laws and Fan Curves. The affinity laws are the airside workhorse. They take one fan at one measured operating point and predict a new one when you change the speed. Flow rides the first power of speed, pressure the square, and power the cube. We'll ground the full printed forms, read a fan curve, then re-rate a single fan for a 25% speed increase, and watch the one-place candidates lose the point, which is swapping those exponents. Concept 1. The same fan workhorse. Take one fan, keep its diameter fixed, keep the air the same, and just change the speed. Flow scales with the first power of the speed ratio, pressure with the square, and power with the cube. Those three exponents, 1, 2, 3, are the entire lesson. Here N is fan speed, Q is volume flow, P is fan pressure, and W is shaft power. This same fan speed-only case is what the exam leans on. Concept 2. The full affinity laws. The printed table carries three factors at once: the diameter ratio, the speed ratio, and the density ratio. Flow goes as diameter cubed times speed. Pressure goes as diameter squared, speed squared, and density. Power goes as diameter to the fifth, speed cubed, and density. For one fixed fan moving the same air, the diameter and density factors are 1, and everything collapses back to the speed-only forms. Notice density affects pressure and power, but never flow. Concept 3. Fan curves and fan types. A fan curve plots pressure against flow at one speed, and the handbook draws these qualitatively for each fan type: airfoil, backward curved, radial, forward curved, and axial. Airfoil and backward curved fans are the high-efficiency ducted HVAC choice. Forward curved run slow and compact. Radial make high pressure for material handling. Axial move lots of air at low pressure. Apply the affinity laws to every point, and the entire curve slides up and to the right. Flow stretches with speed, pressure lifts with its square. Setup. Re-rate one fan for a 25% speed bump. The fan runs at 800 RPM, delivering 10,000 CFM at 2 inches of static pressure on 5 horsepower. We speed it up to 1,000 RPM. Because it's the same fan moving the same air, diameter and density cancel, and the only number that matters is the speed ratio, 1,000 over 800, which is 1.25. That single ratio drives the flow, the pressure, and the power. Solve. Scale the three quantities. Flow takes the first power. 10,000 times 1.25 is 12,500 CFM. Pressure takes the square. 2 times 1.25 squared, which is 1.56, gives 3.13 inches. Power takes the cube. 5 times 1.25 cubed, about 1.95, gives 9.8 horsepower. So at 25% speed rise adds 25% flow, but nearly doubles the power. That cube law is exactly why slowing a fan with a variable speed drive saves so much energy. Traps. 4 ways this bites. 1. The exponent swap, the classic distractor. Flow is the first power, pressure the square, power the cube. Putting the square on power or the cube on pressure is the most missed point on the whole topic. 2. Speed and diameter use different exponents. Don't borrow one set for the other. 3. Density lives in pressure and power only, so warm or high-altitude air cuts both but leaves flow alone. 4. The simple scaling assumes the same fan on a fixed system. Reset a damper or hold a static set point, and it no longer holds cleanly. Quick recall. For a speed change on one fan, apply the exponents 1, 2, 3. Flow with the first power of the speed ratio, pressure with the square, power with the cube. The full printed law also carries the diameter and density ratios. Fan curves plot pressure, power, and efficiency against flow for each fan type. And if you already know the pump affinity laws from thermal fluids, fans are the same shape: flow with speed, head with speed squared, power with speed cubed. Next up, Lesson 4, Fan Selection and the Operating Point. The affinity laws move one fan's curve. Lesson 4 sets that curve against the duct system it feeds. We'll draw the parabolic system curve, find the operating point where the fan and the system meet, and work the fan power, air power, shaft power, and motor input to actually pick the machine. Everything's at pprepengine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at pprepengine.com. Link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.